This is Mr. Beck Does Your Homework. This is AP Physics, homework 9.3, question number 10. In a charging process, 5 times 10 to the 13th electrons are removed from one small metal sphere and placed on a second identical sphere. Initially, both metal spheres were neutral. So I've got one sphere, I've got another sphere, and somehow I'm going to move charge from one to the other. So I'm going to move my 5 times 10 to the 13th electrons from here to here. What that means is that this one, since it lost electrons, is going to become positive, and this one, since it gained electrons, is going to become negative. How much positive and how much negative? Well, it's going to be 5 times 10 to the 13th times the charge on the electron. So this one is going to be 5 times 10 to the 13th times 1.6 times 10 to the minus 19th. So this one is going to be positive by that amount. This one is going to be negative by that amount. So this is going to be Q1. This is going to be Q2. Now it says, after the charging process, the electric potential energy associated with the two spheres is found to be negative 0.071 joules. It's going to be negative because now I can think if I took this sphere and brought it in from infinity, how much work would I do? And since I'll have to be pushing to the right all the way, holding that negative away from the positive, I'm going to be doing negative work, so it's going to have negative energy. So I know that my amount of energy is going to be K times the amount of the first charge times the amount of the second charge divided by the distance between them, not squared. So I am looking for the distance between the charges. I'm looking for R. I know K. I know Q1. I know Q2. And I know U. So U is negative. One of these is negative. Those negatives will drop out. So if you just want to do Q squared equals a positive amount of energy in joules, then this will work out just fine. So that's going to be my R is going to be K, Q1, Q2 over U, or you can just Q squared over U and forget about the negative and get a positive R.